Hello. So we're going to show some example problems of single-step unit conversions as well as multi-step unit conversions. This is also known as dimensional analysis. We're just going to have some examples. I'll have some commentary along the way in the process of how I do things, but it's mostly just examples. I haven't overly rehearsed this because I want you to just see me working on and struggling through the problem. All right, so here we go. All right, so we're gonna have three examples. Today we're gonna have some shorter ones like this, where we're just gonna do a single unit conversion. Okay. Second example, we're gonna have one unit that's not a base unit into another unit that's not a base unit. Okay. And then the last one is we're going to have something involving density. These density ones scare people sometimes because we're working with like two different universes. We have our mass universe, we have our volume universe. Density is a translator for those two universes. It allows us to convert from one universe to the other, mass to volume or volume to mass. All right, so that's the plan. Let's start with example one. All right, so what we got here, okay, 1.23 grams, we want to convert into milligrams. And then after we do that, let's also convert into kilograms. All right, where do we start? We just start by writing the number, okay? And don't be afraid to mark up your sheet with all sorts of notes, okay? Colors, shapes, okay, maybe in an exam environment, they don't allow you to bring in like a bunch of colored pens, but at least for like organizing your thoughts, it's not a bad idea. Okay, that's our start, and then that's going to be our finish. We'll call that part A, and then we'll call this part B. All right, let's start with the milligrams one, part A. So, yeah, let's just write down our starting number. Starting measurement, 1.23 grams. Okay, we want to get rid of grams. So we need to choose an appropriate conversion factor. Okay, one thing I want you to see as I do this is I always write my units first. Okay, so I'm going to write grams here because I know that has to cancel. And then I'm going to write milligrams at the top because I know that's a unit I want to finish with. Okay. Now that I've written my units, okay, we can just kind of check off our boxes. We've done our units. Okay. Now we can put in the numbers. Okay. I like to give a big number to the small unit. Okay. Maybe some of you would have written like a 1 here and a 0.001 there, but I like to stick with giving the big number to the small unit. Okay, now we've done our numbers. Okay. All right. Grams cancel. We're left with just milligrams. Okay. Might as well write that unit down before we forget to do it. And this I can do in my head. Okay, 1.23. We have 3 zeros. So we go boink, boink, boink. Okay, our decimal point goes there. We've created some egg cartons. If it's missing an egg, drop in an egg. All right, so we get 1,230 milligrams. You could have done scientific notation. Oops, that's a 3. 1.23 times 10 to the third power. You could have done that as well. All right, so that was our part A. We did that. Let's do part B. 1.23 grams again. And let me show the bracket style. Okay, means the same thing as like there. That's our multiply sign, the vertex. And then those are our fraction bars. All right, we need to cancel grams again, so I'll put that at the bottom. And we want to end up in kilograms this time. All right, now a little bit of a difference, okay? You may recall that kilo involves a 1,000 somehow, okay? And that is good, that is correct. But milli also involved a 1,000. In part A, milli was our smaller unit, so it got the big number. Whereas in this case, keeping with my same style of giving the big number to the small unit, it is grams this time. That is our small unit. All right, so I'm going to give that the 1,000. And then I'm going to give a 1 to the kilogram. Okay. Goodbye, grams. Hello, kilograms. Okay. So 1.23 divided by 1,000. All right, I can do that in my head as well, or on paper. So now that our number is getting smaller, we got to move the decimal point 3 times for 3 zeros, 3 times to the left, and there's our new decimal point. It's going to create 2 zeros there in the process. So we get 0.0012 Oh, I forgot my unit. All right, kilograms. And if you like to put zeros in front, I don't know, go for it. Okay. So that would be our answer. All right, I'll bust out a calculator every now and then for those who enjoy that. Okay. Don't be intimidated by me like doing some of the calculations in your head. I use a calculator often too, and there's no shame in that. Oops. Times 1. I guess I didn't really need the 1. Divide by 1,000, and sure enough, we get the same answer. Okay, so again, with this example, I showed a few different things, okay? Just a single unit conversion. One reason why I chose these 2 example problems here is I don't want people to assume that the power of 10 is always going to be in the same spot, all right? I don't want you to think like, oh, the power of 10 is always going to be at the top, the numerator, okay? It might be, it may not be, all right? Here we saw it in the bottom, okay? So the more important thing is making sure that the math is correct, okay? And don't just assume where the power of 10 is going to be. Look at the relationship between the units and then give the power of 10 to where it needs to be. Okay? All right. So good. All right, example 2. Now this problem, I want you to see that this is not a base unit, centimeters, and nanometers is also not a base unit. Okay? This may give you a little bit of anxiety. All right, you may be like, well, I only know how to work with base units. Well, that brings a good point. We could maybe use base units to our advantage, okay? And there's a faster way to do this. I'll talk about that too, but me personally, I often do it this slower way using the base unit. All right, so let me talk about what I mean, okay? We know with centi, there are, let's just make a note somewhere on the side, useful stuff, all right? So we have 100 centimeters, 10 to the second power centimeters in 1 meter. That's something we can just memorize or look up, okay? And then another thing is with nanometers. Nano, remember, sounds like 9, kind of anyways. 10 to the 9 nanometers is 1 meter. Okay. All right, so we got these in mind. So knowing this, okay, we can solve the problem. Okay, we can turn centimeters into meters, and then we can turn meters into nanometers. I guess we're kind of going to go like that. Okay. Now, maybe you anticipated, oh, with that piece of information or these two pieces of information, I could do it faster way. If you had that thought, you're probably thinking the correct thing. But I'll show that in a minute. All right, let's do this indirect method first. Okay, so method number one. I'll give it a few different names, an indirect conversion. Okay, or you can call it like multi-step. Okay, let's see how many names I can come up with before it gets boring. Maybe it's already boring. Indirect, multi-step, go to base first. Almost felt like I was gonna say go to bed. Yeah, we all need more sleep in this world. Okay. Yeah. All right, so let's do this. Okay. This first method. Okay. Oh yeah, and the second method. Okay, this is going to be a direct conversion. I like to compare unit conversions to travel, to flight. Okay. Method number one, this indirect conversion. This is going to involve layover airports. Okay. I do realize not everyone's flown. So if you don't understand this analogy, like don't worry too much about it. I think it'll make sense. And then the second one, direct conversion. This is what I'm going to be calling a direct flight. All right. All right, cool. Need a new page. All right, so let's do the, we're still on example number 2, and we're going to be doing method number 1 of indirect. Let's go. So we're going to have this unit plan. We're going to go from centimeters to the base unit of meters, and then from there we're going to go to nanometers. Okay. This is airport A. This is airport B, where we have our leftover. Then we finally end up in C. Okay. So we want to end up with nanometers, which means as we're doing this, we're going to cancel the original unit we start out with, the centimeters, and we're also going to cancel this intermediate unit of the meters. We don't want to end up with either of them. We only want the unit that we want. Okay. All right, so let's do it. Okay, so we have 42.1 centimeters. Write my units first. We're going to go to meters first, indirectly. Okay. And then we're going to leave the meter world, and then we're going to go to nanometers. And there is my setup. Okay. All right, so I got 100 centimeters in 1 meter. And in 1 meter, we have 10 to the 9 nanometers. Again, I'm just pulling from here. Okay, let's cancel out our units. Okay, I love canceling units, almost as good as a slice of New York style pizza. Right, and then here's the units we wanted it to end up with. Okay. All right, so we calculate. I just feel like doing one line on the calculator today. I don't feel like thinking anymore. All right, so we go 42.1 times 1 times 10 to the 9. Divide, I'm going to open a parentheses. 10 to the second power times 1, close parentheses, hit equals. Oh, man. Let's see if I can scientific that. All right. If you're wondering how I did that, second psi engineering flow. I don't even remember what that stands for, but I go to scientific. Okay, so 4.21 times 10 to the 8th power. Or you could just count your zeros. Or decimal places, excuse me. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's good. Okay. And then we get nanometers. Okay. If you're trying to do this in your head or all calculators in the world like stopped existing, then there's a way you can do this by hand. Okay, we would have 42.1 times 10 to the ninth power. Okay. And then we could just bring that up. Let's do that, times 10 to the negative second power. If you realize that 42.1 is also the same as 4.21 times 10 to the 1 power, then we can just combine these exponents, add them. 1 plus 9, 10. Minus 2 is 8. All right, nanometer. Okay. Oh no, I drew on my desk. Okay, but there's the answer. Okay. Now I know some of you out there are wanting a faster way of doing this. All right, so let's go to like method 2. And we're still doing example number 2. And you want that direct method. Okay. Okay, direct method means you need to create a conversion factor between your starting unit of centimeters directly to your end unit of nanometers. Okay, you need something direct. Okay, so earlier we wrote this. Okay, earlier we wrote this. So one approach you could do is you could say, all right, 10 to the second centimeters is the same as 1 meter is the same as 10 to the 9 nanometers. Okay. We can cut out that part. And then we can get that. And then we could divide that into this side or the other way around. I'm going to divide this into that side. That way, I'm going to end up with a positive exponent. I just love positive exponents more. All right, so that means I'm going to have to move this. So I'm going to just divide both sides by 10 to the second power centimeters. Of course, this will entirely cancel to become a 1. Okay. So that's pretty good. You could just leave it that way and like actually you'd be done. Okay. You could also just say, oh, 10 to the second power goes into 10 to the 9 by removing 2 zeros. In other words, you would get 10 to the 7th power nanometers in 1 centimeter. And then you would end up with that conversion factor. Okay. Either of these actually work. Okay. Math is math. These two are the same thing. So you could put either into place. Okay. All right. Let me show that. Gotta prove it. Gotta prove it. All right. So here's my work. I don't know why I just wrote that. Whatever. Okay. So we're going to go direct. We started out with 42.1 centimeters. And now that we have this nifty piece of information, oh, and even nicer, this was just, I guess, lucky maybe, but we have the nanometer part on the top and the centimeter part in the bottom just the way we need it. Oh, I broke my rule. I have to write the units first and then the numbers. Okay, there we go. All right. And you will get the same answer there. Keep this video short. I'm just gonna have you verify that. And then the other way we could have written this, not as simplified, but whatever. And you would get the same answer that way as well. Okay. Okay, do it yourself if you need to confirm for yourself. Okay, I do recommend that. Again, don't just trust everything I say. You got to try it for yourself, not just to get it right, but so that you develop the muscle memory, the mental memory, whatever it's called, to know how to do it. All right. I'm going to show even another way of doing that method directly. Okay. This involves creating a quick like metric cheat sheet. I guess not everyone likes the word cheat. And we're not cheating. We'll just say reference sheet. Okay. So you can just go like kilo, base, centi, milli, micro, nano. You can even put the prefixes. And then you just write out powers of 10. And then you can just see going from centi to nano that we have a 10 to the 7 power difference, okay, between the 9 and the 2. And if you remember that things are going bigger that way, that's an arrow. I know I'm not going to win too many awards with my handwriting, but things are going bigger that way, then you would know to give the 10 to the 7th to your smaller thing, the nano. All right. And then from there, you have your conversion factor between them, and then you would end up with an identical setup to that one. All right, cool. All right, now that we have some experience with that, let's go to a final, more challenging problem. Here's that density one I was talking about earlier. All right, so what we got is we have a block, block of aluminum. All right, and it's 0.95 cubic inches about. Okay, I measured it. It's not exactly 1 square inch. It's a little bit square inch, cubic inch. It's just a little bit smaller than that. All right, and then the problem says this. Okay, they give you a volume, but they want you to calculate a mass. It's like, huh? But they do provide some data and information. All right, they tell you, oh, here's the density of aluminum. I guess I should put a D. Okay, the D of aluminum. Okay, density of aluminum, you have 2.70 grams of aluminum in 1 cubic centimeter of that aluminum. And they also remind you 2.54 centimeters is equal to 1 inch. And they say have at it. All right, so I got a unit plan written here. Maybe I shouldn't have shown that yet. Maybe I spoiled the fun for you, but this is my plan, all right? And the reason why I like this plan is, well, we have to start with cubic inches. That's what they gave us. We can't negotiate that. And we have to end with milligrams because that's what they asked of us. We can't negotiate that either. But with this information provided, I see a route forward, okay? The density allows us to translate between volume and mass, okay? So I know we need to end with a mass, but we're given a volume. So we're going to get this involved somehow to change from the volume world to the mass world, okay? The only issue being, though, that this density has grams and cubic centimeters. Grams and cubic centimeters. It doesn't have the cubic inches that we're actually working in. So we can convert that, though. We can use this piece of information, okay, right there, okay? And then once we've gone to cubic centimeters, we're going to use as density. I know it's getting a little bit messy here, to go from the volume world to the mass world. And then this last part, we're going to, it wasn't provided, but since it's a metric conversion, metric conversions, depending on your instructor, it's not like always provided. Some will provide a metric system, others don't. It's my recommendation that you commit to memory some of these metric prefixes, especially the most common ones, even if you're not required to memorize. It's just good to know, okay? But we would use this relationship knowing the metric system, and that gives us a path forward, okay? Now, what I didn't say yet, but we're going to take care of, is you may have noticed that this conversion factor between centimeters and inches is only in one dimension, okay? But this is three-dimensional. We will take care of that. That will be taken care of. All right, so let's do the problem. All right, so I have 0.95 cubic inches. Time for my first conversion factor. All right. I'm going to write 1 inch for every 2.54 centimeters. Okay. Oh, looks like I wrote my numbers before the units again. All right. So I guess here's a real truth on that. If you have some conversion factors known by heart and it just flows out of your hand correctly automatically, okay, fine. I guess you can break the rule. But if you're not feeling a good grasp on those conversions yet, then you'll definitely want to write the units first before the numbers. Okay. There's the gray area truth, I guess. Okay. Now, again, this is just a single dimension. So that means in order to get rid of the cubed inch and create a cubed centimeter, I have to do this 3 times. Oh, I might have to squeeze this in a little. Yeah, I'm going to need a new paper. Okay. Now, I'm not going to edit this out because I want people to see that work is a messy thing. I'll probably sometimes edit out mistakes like that, but not this time. 2.54 centimeters. And just copy and paste that. Copy and paste one more time. Okay. All right. Let's take a pause. We're going to cancel out the cubic inches and we'll end up with cubic centimeters. All right, I forget where I'm going. Let's go back to our unit plan. All right, we got cubic centimeters now. We got to go to grams. Okay, we can do that. We have the good old density of the aluminum. Okay. Now let's see. We want to cancel out cubic centimeters. Right now, cubic centimeters is at the top. So we're going to have cubic centimeters at the bottom. Hey, see, I didn't write the number this time. Okay. And then I'm going to put grams at the top so that I have mass at the top. Okay. Now I can just drop in those numbers. So I got 2.70. and then I have the 1. Densities aren't always written with like the 1 at the bottom, but if it's not written, you can infer that there's a 1 there. All right, and then lastly, now that I'm going to be in grams, I can use this piece of information again, the milligrams. Right, and we have 1,000. I'm running out of space. I'm just going to use the scientific or the power of 10, 10 to the third power. 10 to the third power milligrams for 1 gram. Right? Huh, what do you look at that? I have 1s at the bottom this whole entire time. Um, as a teacher, I wanted more complicated stuff at the bottom, but whatever. Sometimes that happens. All right, so cubic inches. And then cubic centimeters. Grams. Starting to run out of colors. Orange. And we'll use the violet purple for the units that survive. Milligrams. All right, I really can't believe it's just a bunch of 1s. But yeah, that's right. That's right. That's right. That's right. That okay. All right, fine. Okay, so let's type this into the calculator. Sure, I'm still on the screen. 0.95 times 2.54. Might as well do the cubed button like that. Buttons. Or sure, write it 3 times. We don't care. Okay. And we get this number. Okay, I'm not going to talk about rounding rules, significant digits in this video. That's going to be a future video. Let's see, 4203. We'll just round it there, comma, if you want it. Okay, if you're wondering about sig figs, if you're like, I already read about that, that would be the correct answer. Or this would be the correct answer. Okay. And I'll explain why in a future video. All right, now some of you may prefer this way. I like writing it out this long way, but some people they are pretty comfortable with exponents and maybe they'll want to condense this, and that's totally okay. You could just go something like this. 1 inch, cubed over 2.54 centimeters cubed, like that. And you would get the same result. You could just leave the 2.54 centimeters in parentheses with the cubed sign outside like that, or if you really want, you could like pre-cube it 2.54 to the third power. That's a lot more to write, but sure, if you want. Okay. All right, those were some examples. And yeah, I guess here's our little cliffhanger, especially with the significant digit sig figs. How do I know that I'm supposed to actually round to that? Okay, that's going to be a future video. I'm not going to give any spoilers here. All right. Thanks for watching. Have a good day, night, day, whatever time of day it is for you. And any questions, leave them in the comments.